In the quest to understand consciousness, scientists and philosophers have explored numerous avenues, from neurobiology to computer science. However, one of the most intriguing and controversial approaches comes from an unexpected direction: quantum mechanics. At first glance, the laws governing subatomic particles might seem worlds apart from the rich tapestry of human experience. Yet, as we delve deeper, surprising parallels emerge between the bizarre world of quantum physics and the equally mysterious realm of consciousness. Imagine for a moment the strange behavior of particles at the quantum level. They can exist in multiple states at once, a phenomenon known as superposition. Similarly, our minds can hold conflicting thoughts or emotions simultaneously. Another fascinating aspect is quantum entanglement, where particles remain connected no matter the distance. Could this be akin to the deep, inexplicable connections we feel with loved ones even when they're far away? In this video, we'll explore these fascinating connections, examining how the fundamental principles of quantum mechanics might offer new ways to understand and describe subjective experience. While these parallels don't necessarily prove that consciousness operates on quantum principles, they provide a compelling framework for rethinking the nature of mind and its place in the universe. Stay with us as we unravel the quantum mysteries of the mind. You might just discover a new perspective on your own consciousness. In quantum mechanics, the act of measurement causes the wave function to collapse, forcing the quantum system into a definite state. This process, known as wave function collapse, is one of the most puzzling aspects of quantum theory, raising questions about the nature of reality and the role of observation. A striking parallel exists in our subjective experience of decision-making. As we contemplate a choice, our mind exists in a state analogous to quantum superposition, entertaining multiple possibilities. The moment of decision can be likened to a wave function collapse, where the multiplicity of potential choices collapses into a single definite action. This parallel extends to the realm of creativity as well. The crystallization of a vague notion into a clear idea bears a remarkable resemblance to wave function collapse. Just as quantum measurement brings a particle's state into sharp focus, the creative process often involves a sudden clarification of previously nebulous thoughts. Quantum entanglement, famously described by Einstein as spooky action at a distance, refers to the phenomenon where particles become connected in such a way that the quantum state of each particle cannot be described independently, even when separated by large distances. While human beings are far too large and complex to be quantum entangled in the literal sense, our subjective experiences of connection with others often mirror this quantum phenomenon. The deep bonds we form with loved ones, the sense of shared experience in a crowd, or moments of profound empathy where we seem to feel another's emotions as our own. All these experiences evoke a kind of psychological entanglement reminiscent of quantum connections. Moreover, the non-local nature of quantum entanglement finds a parallel in how we maintain connections with others across vast distances. The instant sense of connection we feel when thinking of a loved one far away, or the phenomenon of simultaneous invention where multiple people develop the same idea independently, hint at a kind of entanglement in the collective human psyche. Heisenberg's Uncertainty Principle states that it's impossible to simultaneously know both the position and momentum of a particle with perfect precision. The more accurately we measure one property, the less accurately we can know the other. Just as we cannot simultaneously pin down a particle's position and momentum, we often find that the very act of introspection alters the mental state we're trying to observe. When we try to examine our own consciousness, we inevitably change it. Attempting to observe our thoughts often disrupts their natural flow, much like how measuring a quantum particle disturbs its state. This parallel suggests that there might be fundamental limits to our ability to fully grasp the nature of consciousness through direct observation. In quantum mechanics, particles can sometimes pass through barriers that would be insurmountable, according to classical physics. This phenomenon, known as quantum tunneling, allows for possibilities that seem to defy common sense. Imagine a particle encountering a barrier. Classical physics would dictate that if the particle doesn't have enough energy, it should be stopped. Yet in the quantum world, the particle can sometimes be found on the other side, as if it had tunneled through the barrier. This mysterious phenomenon finds an intriguing parallel in the realm of human consciousness. Have you ever experienced a sudden flash of insight, an intuitive leap that bypassed logical steps. Much like quantum tunneling, our minds can sometimes jump over mental barriers, arriving at solutions or ideas that seem to come from nowhere. Creative problem-solving often involves such quantum-like tunneling. Picture yourself struggling with a complex problem, unable to find a way forward. Then, out of the blue, an aha moment strikes, and the solution becomes clear. This intuitive leap mirrors the unexpected possibilities opened up by quantum tunneling. Quantum coherence occurs when particles act in a coordinated manner, effectively behaving as a single quantum system. This coordinated behavior allows for phenomena like superconductivity and superfluidity. In the realm of subjective experience, we find a parallel to quantum coherence in flow states or peak experiences. During these states, various mental processes align seamlessly, creating a sense of effortless action and heightened performance. Athletes in the zone, musicians in perfect harmony with their instruments, or meditators experiencing a sense of oneness all report experiences that evoke the coordinated behavior of quantum coherence. The sense of losing oneself in an activity where action and awareness merge mirrors the way individual particles lose their separate identities in a coherent quantum state. In quantum mechanics, probability waves can interfere with each other, creating patterns of constructive and destructive interference. This interference is key to many quantum phenomena and is demonstrated dramatically in the famous double-slit experiment. Our thought processes often exhibit patterns reminiscent of quantum interference. Different ideas or memories can interact in complex ways, reinforcing each other, constructive interference, or cancelling each other out, destructive interference. The way certain thoughts can amplify or diminish others, creating complex patterns of association and meaning, mirrors the interference patterns seen in quantum systems. This parallel is particularly evident in how we process conflicting information or emotions. The simultaneous experience of joy and sorrow, for instance, doesn't result in a simple averaging of the two emotions, but rather in a complex interference pattern of feeling that can produce entirely new emotional states. The idea that the very act of observation can affect the system being observed. In the realm of consciousness, we find a striking parallel in how self-awareness affects our mental states. The act of focusing attention on a thought or feeling often amplifies or alters it. Our mood can change simply by becoming aware of it, and our behaviors can shift when we know we're being watched, even by ourselves. Quantum non-locality refers to the ability of quantum systems to exchange information instantaneously, regardless of the distance between them. This spooky action at a distance, as Einstein called it, seems to violate our classical understanding of causality. In the realm of subjective experience, we find a parallel to quantum non-locality in intuition and sudden knowing. People often report experiences of immediate understanding or insight that seem to arise without any apparent causal connection. The sense of just knowing something without being able to explain how we know it bears a resemblance to the instantaneous information exchange in quantum non-locality. This parallel is particularly intriguing when considering phenomena like collective intuition or the sense of being connected to a larger field of consciousness. The quantum Zeno effect is a curious phenomenon where frequent observation of a quantum system can inhibit its evolution. In essence, constantly checking on a quantum system can freeze it in its current state. This quantum principle finds a fascinating parallel in how constant self-monitoring can affect our mental states. When we obsessively check our thoughts or emotions, we often find that they become stuck or fail to evolve naturally. This is particularly evident in conditions like anxiety, where constant self-monitoring can perpetuate the very states one is trying to change. The parallel suggests that there might be an optimal balance between self-awareness and allowing our mental states to evolve naturally. In quantum field theory, the vacuum is not truly empty, but is instead filled with constant fluctuations, virtual particles that pop in and out of existence. These quantum vacuum fluctuations are thought to be the source of many fundamental physical phenomena. Our stream of consciousness bears a striking resemblance to these quantum fluctuations. The constant arising and passing of thoughts, the background noise of our mental life, mirrors the ceaseless activity of the quantum vacuum. Just as virtual particles emerge from nothing and quickly disappear, our thoughts often seem to arise spontaneously and vanish just as quickly. This parallel suggests that what we experience as consciousness might be akin to fluctuations in an underlying field of awareness, much like how physical reality emerges from fluctuations in quantum fields. The many-worlds interpretation of quantum mechanics proposes that every quantum event splits the universe into multiple realities, each representing a different outcome. While highly speculative, this interpretation has captured the imagination of scientists and the public alike. In our subjective experience, we often have a sense that alternative choices or paths are somehow real or actualized in parallel experiences. The road not taken doesn't simply disappear from our consciousness, but often lingers as a kind of parallel narrative. This sense of multiple possible realities coexisting in our minds mirrors the many worlds concept. When we make decisions, we often feel as if we're navigating through a multiverse of possibilities, each choice creating a new branch in our personal history. As we journey through quantum mechanics and consciousness, the parallels between quantum mechanical laws and subjective experience are both striking and thought-provoking. From the superposition of thoughts to the entanglement of minds, from the uncertainty of introspection to the tunneling of intuition, our inner lives seem to echo the strange and wonderful world of quantum physics. It's important to note that these parallels don't necessarily prove that consciousness operates on quantum principles. The brain is a warm, wet environment, very different from the controlled conditions needed for most quantum experiments.